He's a boss. All right, the graph of a quadratic function is a good old parabola. Okay, so what is a parabola? Well, let's first write what a quadratic function is in a basic just terminology here. You would have ax squared, degree 2, squared, plus bx plus c. That's your very basic form for a quadratic function, okay? If the a right here is bigger than 0, so if it's positive, okay, you would open up. It would make a u. It would be happy. A is less than 0, it opens down, okay? It's downward. Makes sense. Easy stuff. So other parts of the parabola that you just need to know and recognize, we'll just here. All right. So where the parabola intercepts the y, okay, that is your y-intercept. That is always your c value. Your c value is your y-intercept. The number all by itself is your y-intercept. Cool. So if it's like x squared plus 2x plus 8, it's going to intersect at 8. If it's a negative 5, that's where it's going to intersect. If it doesn't have it there, it's going to go through the 0, 0. Okay, that's your y-intercept. There is an imaginary line that goes down to this lowest point right here. This lowest point right here, first of all, is called the vertex, or it could be the highest point, your vertex. There is an imaginary line that goes through it. It's called an axis of symmetry. It's an axis and it's symmetric because you could literally fold this piece of paper right along this imaginary line and they would hit each other. So that imaginary line is called axis, oops, I'm running out here, axis of symmetry. Your axis of symmetry is always written as x equals a number because any vertical line is always written as x equals a number. Again, let's go back to Miss Amy Davisisms. However Knox. And I know you didn't know what that means, but vertical lines, Knox is no slope x. X equals, okay? That's where it comes from. I know. There is an equation to find the axis of symmetry. You would actually write x equals negative b over 2a. Negative b coming from your standard form right here, the x over 2 times a. And that would, you would have the axis of symmetry right there. Pretty easy. Okay, so first part, let's do an example of all this stuff, all this lovely information now. Probably, but we'll see. So number 1, let's do what it says. What's the y-intercept? The number all by itself, the c, exactly. So I usually write it as a point, 0, negative 3. So I know when I go to graph it, 0, negative 3 would be down here. I know the u is going to go through that, either up here or down here, which actually we know right now. Is it going to go up or is it going to go down? It's going to go up, it's positive. So I know it's going to be upward. Number 2, your axis of symmetry is, again, x equals negative b over 2a. So my b is 2, so negative 2 over 2 times 1, is 2. So negative 2 divided by 2 is 1. So x equals 1. So at the imaginary line 1, it's negative 1, isn't it? Yeah. Yep. Thank you. I was like, I can see my graph and it's totally wrong. There we go. So at the imaginary line negative 1, which is right here, just make a dashed dot line. There we go. So your u would, you actually could find this reflective point right here. This reflective point of 0, negative 3, you can reflect it over here. You know it's going to go like that because it's going to flip over that line. So now let's find the vertex. So the vertex is really cool in that the vertex has to, if we know that x is negative 1, couldn't we just plug it in here to find the y, right? So let's find f of negative 1. So that would be negative 1 squared plus 2 times negative 1 minus 3. What is it? Negative 4? Yeah. So negative 1, negative 4 is your vertex. -1, -4, which would be right here. There you go. And then you can just graph it. Okay. But let's talk about something. This is really important. I hope you can remember. Do you know what that point is called beside the vertex? Starts with an M. Max and min. You remember those words? Okay. This is would this be a min or a max? Why is it a min? It's the lowest the graph can go. That makes sense, right? This is all making sense to you? Okay, so let's write that down. Let me add a paper. So if you have your picture like this, that's a minimum. And if your picture goes, what part of the quadratic is this? This is the vertex. So your calculator can get max and mins. Did you know that? Yeah. So if I want to, let's do an example of that. Find, just to refresh you on how to do this in your calculator, you go to your y equals, type in your equation, hit zoom 6, that's your basic standard view. It might not fit in there, but you should be able to see it. So yeah, it's not fitting in, but that's okay. Your calculator still knows what to do. Did you see how it started, right? It went up and it went down. So it's like, okay, so we know that this is a max or min, which one? So we know it's a max. Okay. We want to find that max. The way you do it is second calc, and then here it says min max. So we go to max, don't hit min. It will give you totally, it's sometimes right and sometimes wrong. So everybody, please just make sure you hit max because we're talking about max. It's going to ask you 3 questions. It's going to say left bound, right bound, guess. Left bound, right bound, guess. That's why Amy Davis always is like, second 5, enter, 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 right? It always asks you 3 questions. So second calc, max, and then you have to answer left bound, right bound, guess. So just make your cursor go to the left of it. There's my cursor. You see it? And it doesn't matter where you put it. Just hit enter. Then go to the right of it. Come on. Come on. It's pretty high max. There we go. Hit enter. Then it says guess. Hit enter again. And look at there. I'm at 223. Well, guys, that's your vertex. Get out of town. So if it ever asks you for vertex, just find the max or the min. Well, then this could all make sense then. What would be my axis of symmetry then? X equals 2. What? Get out of town. Let's just go there. What's the y-intercept? Oh my gosh! So like this is what's so cool about math. It's like it all comes together in one thing. You should know how to do it. All right? Oh, but let's answer the second part. What's the domain? Yeah. So the domain again, for those who don't remember, is how wide would my hands go if I had to keep the x-axis going? Okay, so if I had to pull on the x-axis, would my hands have to keep going? Yes, they would, right? Wouldn't this keep going and going and going and going? Like I would have values. So you would say all reals. That's that double R thing. What's the range? How tall is this picture? Well, it definitely keeps going down here, but eventually, where would I stop? Yeah, so y, you would say y is less than or equal to 23. Okay, we're going to do interval notation soon, which some of you may have done or not. All right, and the last 3 things that we're going to talk about is how to solve quadratics. So we just graphed quadratics. The max is the vertex, the min is the vertex. The axis of symmetry is right there in the vertex. I mean, it's cool. All right, so step number 2, solving quadratics. And I do this what's called a rainbow. and you do 3 times negative 2. You multiply these two together. What's 3 times negative 2 make? Okay. And then the middle is what you want it to add up to. So you want it to add to a 1, right? You all agree? Okay, can you think of two numbers that multiply to negative 6 but add to a 1?
Negative 3 and 2. Negative 2 and 3.
Yeah, okay. So you all trinomials factor into two binomials. So you put x here. Then you put the two numbers that you just thought, negative 2 and positive 3, there. But because there's a number in front, this only works if there's a number in front, you have to, like, even if it was a 1, you would divide by that bottom number. And then if you can reduce. If you can't, you bottom it up. Have you heard her say bottoms up? Okay. So what does this reduce to? 3 divided by 3 is? So x plus 1. This can't reduce, so you bottom up the 3 next to the x. So it's 3x minus 2. That's it. So what are my two answers right here? What are my two solutions right here for x? X is what or what? 2/3 and positive 2/3. Why is this important? We're going to find out why. Those two numbers right there, you should remember it from last year. That is actually where the quadratic will intersect the x-axis. Those zeros are called x-intercepts. So at 2/3, which is like here, and then negative 1, which is here, that's where it would intercept the x-axis. It's really important because you have to learn how to do this without a calculator. All right, and then this other one method nobody likes. No, I take it back. This one you like. It's your A is 1. So x equals negative b. So this would be your b. This would be your c. This would be your a. Always set it equal to 0. So negative of negative 4 is 4. Whoops. Plus or minus the square root of b squared, 16, minus 4 times 1 times a 15. 60. 60? Yes, I am right. God is good. Over 4 times 1. Okay, and then let's clean this up. This would be 4 plus or minus square root of negative 44. Am I 44? Yes. Okay. And then what can that clean up? We just did these negatives right here. So what would that be? 4 plus or minus 4 times 11, right? What's the square root of 4? 2. So 2, pull out that negative. I root 11 over 4. And then you can even clean this up even more. So this would be I square root 11. Okay. What does this mean? So we're going to find this out. When you end up with i's, you end up with a parabola that's like, it's not even crossing the x-axis. Not with imaginaries. It's like way up there or floating down there. Okay. So factoring, quadratic formula, and you're going to hate this. Complete the square. This is the. So let me just show you how to do this. It's not really that hard. You always take your number by itself and move it over. That's just the first thing you always do. You only want your x's on one side. So x squared minus 6x. And then you write this, plus blank. I think she makes a box. Equals negative 1 plus blank. Okay. What goes in that blank is what we call the completion of the square. And what you do is you take half the middle and then you square it. That's what goes in the blank. Half of negative 6 is what? And what's negative 3 squared?
9.
That's what goes here and here. And I only ever complete the square, by the way, if this is even. If this is odd, I hate completing the square. There's no point in it, right? Am I right? 5 divided by 2, 5 halves, square it, 25 fourths. Who wants to deal with that? I mean, we will in calculus, but it's just not worth it. Now, once you get to this point, clean it up. Do things that you've done, meaning rewrite this in a factored form. This is what squared? This is x minus 3 squared. It's always whatever you took a half of. It's always half. Oh, it's -3, right? So we took a half off. It's always that. Equals, what does this side become? 8. And now you take a square root, because that's how you would solve this equation for x, because that's what we're doing. Remember, we're solving for x by completing. Take a square root, take a square root. They cancel. What do you need to remember whenever you take a square root from the last class? Yeah, you do. Plus or minus. 8 is actually 2 root 2. And then I like to bring the 3 in front. 3 plus or minus 2 root 2. Had you done this quadratic formula, you would have gotten the same answer, literally 3 plus or minus 2 root 2. But really the biggest thing is bring the number over, blank and blank, half the middle, square it, and then start doing your solving process. Take the square root, and it works out well, okay? So that was it. It's a lovely day.